Hello and welcome to PMP certification course offered by Simplilearn. In this lesson, we will focus on project time management. Let us begin with the objectives of this lesson. After completing this lesson, you will be able to define project time management, explain project schedule, Gantt charts and network diagrams, identify the key terms used in project time management, describe the project time management processes, explain various schedule network analysis techniques. In the next screen, let us take a quick look at the project management process map. There are 47 processes in project management grouped into 10 knowledge areas and mapped to 5 process groups. In this lesson, we will look at the third knowledge area, that is, project time management and its processes. Let us begin with the first topic of this lesson, project time management. The purpose of project time management is to ensure that the projects get completed on time. This knowledge area is primarily concerned with developing a project schedule and ensuring that project goes as per the agreed schedule. If there is a need to change the project schedule, the change should happen by following a proper change control procedure. Another term used in the PMP examination is Schedule Management Plan. Schedule Management Plan is part of the Project Management Plan and has information on the planned project schedule and its management and control. Let us discuss the key activities of project time management in the next screen. The key activities that are part of the project time management include identifying activities, estimating time and resources, and sequencing activities. It is important to identify a list of activities that would be a part of the project. Next, an estimation of time and resources required for completing the identified activities are done. Finally, these activities need to be sequenced as per the dependencies. In the next screen, let us discuss project schedule. Project schedule represents the time dimension of the project plan and has information like when the project would start, when each of the project activities would happen, in what order the project activities would happen, when project would be completed, etc. Usually, software system is used to develop the project schedule. The project team can enter the list of activities in the software, as well as their dependencies, and the software can produce the project schedule as the output. Microsoft Project is the most popular tool used for project schedule development. Generally, project schedule is considered similar to project management plan. Project management plan is different from project schedule. Project management plan not only has information about the project schedule, but also other important project-related plans, like risk management plan, cost management plan, etc. Let us focus on Gantt chart in the next screen. Gantt chart is a type of bar chart that illustrates a project schedule. It shows the dependencies between the project activities as well as their percent completion. A sample Gantt chart is shown on the screen. 2 summary elements of the work breakdown structure are depicted. To complete those elements, there are a number of activities under them. Some of these activities have dependencies. For example, Activity B and C have a dependency. Activity C can start only when Activity B is completed. The chart gives you an idea about when specific activities are planned to finish and when the overall WBS element will get delivered. Create tasks and work with the Gantt chart. This will make answering Gantt chart-based questions easy and fun. In the next screen, let us understand the relationships that exist among project activities. Network diagram is extensively used in the project time management knowledge area to plot the activity dependencies. This is a graphical representation of the project activities in the form of a network. There are 2 ways to draw a network diagram. In Precedence Diagramming Model, PDM, or Activity on Node, AON, boxes represent activities and the arrows indicate the dependency. This type of network can have all four types of relationships between the activities. In Arrow Diagramming Model, ADM, or Activity on Arrow, AOA, the arrows represent activities. The relationships and sequences can be inferred from the direction of the arrows and linkages between the activities. In such types of network, only finished-to-start relationships can be shown. Such diagrams may need to make use of dummy activities to indicate some dependency between the activities. There may be questions in the PMP exam based on the network diagram, so create and work with the diagram. This will make answering network diagram-based questions easy and fun. In the next screen, let us look at a network diagram. A sample network diagram is shown on the screen. Activities A and C can happen in parallel. B and D require both A and C to complete, whereas E requires both B and D to complete. Activity on Arrow network diagram makes use of hammock activities. They are used to show a comprehensive summary activity combining several other activities underneath for control and reporting purposes. In the next screen, let us look at a few important terms in time management. When a successor activity can start before the predecessor activity can complete, it is considered lead. For example, you can start preparing the test environment 2 weeks before the development activity finishes. When the successor activity has to wait for a few days after the predecessor activity has been completed, it is considered lag. For example, one needs to wait for 2 days for the foundation to settle before work on the pillars for the next floor starts. Rolling wave planning is an iterative planning technique in which the work to be accomplished in the near term is planned in detail, while the work in the future is planned at a higher level. It is a form of progressive elaboration. In the context of estimating techniques, analogous estimating is based on the previous project data. Therefore, if the last 5 similar projects took 6 months to complete, the next one will also take 6 months. This technique employs expert judgment. Another estimating technique is parametric estimating. This technique uses a mathematical model to calculate projected time for an activity based on the historical records from previous projects and other information. A few common parameters are identified based on the previous project data, and that parameter is used to predict the time required to complete the next activity or project. For example, you can normally complete 10 kilometers of highway construction lanes a week. Effort is the total amount of work required to complete the activity. Duration is the amount of time it takes in terms of elapsed or calendar days. If you have an activity that requires 10 people to work for 5 days, the total effort is 50 person days, but the duration is only 5 days. In the next screen, let us look at the project time management processes. There are 7 project time management processes. They are plan schedule management, define activities, sequence activities, estimate activity resources, estimate activity durations, develop schedule, and control schedule. The first 6 processes are executed during the planning process group. The ultimate goal of these planning processes is to develop the project schedule. The 7th and the last process is a part of the monitoring and controlling process group. In the next few screens, let us discuss these processes in detail. We will begin with plan schedule management. As defined in PMBOK Guide, plan schedule management is the process of establishing the policies, procedures, and documentation for planning, developing, managing, executing, and controlling the project schedule. It belongs to the planning process group. Let us look at the inputs to this process. The project management plan provides other subsidiary plans and will guide the schedule planning activities on the project. The project charter provides an overall context and the high-level product and project description, which might help determine the approach for schedule management. Few projects might have scheduling constraint. For example, projects of Olympics 2016 should be completed at the same time. Enterprise environmental factors provide the organizational context to the project, including the culture of the organization, the infrastructure like scheduling systems available, key personnel, and so on. Organizational process assets provide inputs such as policies and procedures, templates, past performance data and estimates, historical information, and knowledge base. Now, let us look at the tools and techniques employed in this process. Expert judgment refers to input received from knowledgeable and experienced resources. Experts can draw from their previous experiences the proper approach to govern the schedule on a project. Meetings may be organized to determine the schedule management plan. Anybody responsible for the project schedule management, such as the project manager, sponsor, customer, and other stakeholders, must attend these meetings. Several analytical techniques may be used to determine the schedule management plan. These may include different planning approaches and philosophies, such as rolling wave planning, or different scheduling software that allow to build what-if scenarios and study the effect of advanced scheduling techniques like leveling, fast tracking, and crashing. Now, let us look at the outputs of this process. Schedule management plan is a component of the project management plan that describes the criteria and activities required to arrive at the project schedule, as well as how the project may be baselined, monitored, and controlled. In the next screen, let us define activities process. Define activities is the process of identifying the specific actions to be performed to produce the project deliverables. It belongs to the planning process group. The important input for the define activities process is the scope baseline. Scope baseline is a term used collectively to refer to project deliverables, constraints, and assumptions of the project. In addition to the scope baseline, the other inputs in this process are enterprise environmental factors, organizational process assets, and schedule management plan. A reason why enterprise environmental factors is an input to define activities is because the organization might be using project management software to define activities, and that may influence the activity definition process. The knowledge base containing historical information regarding activities lists used by previous similar projects is a good example of organization process assets applied to scheduling. The tools and techniques used in defining activities are decomposition and rolling wave planning. The last technique is expert judgment, where the experience of project team members is used in developing detailed activity lists. The output of the process is activity list, activity attributes, and milestone list. Activity list contains a list of identified activities. Activity attributes are the additional information about the activity itself. A milestone is a significant point or event in the project. A milestone list identifies all the milestones and indicates whether the milestone is mandatory or optional. Let us move on to the next process, sequence activities. Sequence activities is the process of identifying and documenting relationships among the project activities and is also part of the planning process group. For every activity and milestone, except the first and last one, is connected to or at least one predecessor and one successor. The inputs to this process are activity list, activity attributes, and milestone list. All these are the outputs of the define activity process. The other inputs are schedule management plan and project scope statement. Schedule management plan provides guidance in terms of methodology to be employed for many of the scheduling activities on the project. Organization process assets are also an input to sequencing activities because the organization might have some kind of knowledge base for scheduling project activities. The enterprise environmental factors relevant to this process may be scheduling tools in use, project management information systems, work authorization systems, etc. One of the important tools and techniques used in sequencing activities is the precedence diagramming method. In this method, the activities are drawn on a network diagram and all the different kinds of dependencies between the activities are determined. While determining activity dependency, it is important to identify the type of relationship or dependency between the activities. The other technique is leads and lag, which is widely used for sequencing activities. The output of the process is the project schedule network diagram, which is a graphical representation of the project activities in a form of network, which also shows the activity dependencies. While designing the network diagram, new activities might be identified, and that would result in some of the project document updates, especially the ones that list all the project activities. In the next screen, let us look at the Estimate Activity Resources process. After sequencing the activities, the next step in project time management is estimating the resources required to accomplish each of the identified activities. Estimate Activity Resources process also belongs to the planning process group. Here, resources do not mean only the human resources, but includes all other resources like equipment, raw materials, machinery, etc. Schedule Management Plan is the first input. Schedule Management Plan provides guidance in terms of methodology to be employed for many of the scheduling activities on the project. The other inputs to this process are an activity list and activity attributes that are the outputs of the time management processes. Risk Register is another input. Risks to the project may influence the decisions about the resources that need to be deployed. Hence, Risk Register becomes an input to this project. In addition, activity cost estimates are another input. Cost and resource estimates on a project are interrelated and influence each other. For example, the cost might dictate the number and type of resources that can be employed, or the time might dictate the cost that may need to be incurred. Along with this, the resource calendar is also an important input because it has the information about the availability of each of the resources. Some of the enterprise environmental factors that can influence estimating activity resources are availability of required resources within the organization. The organizational process assets is also an important input, as the organization might have standard policies for staffing or for hiring contractors on the project. With all these inputs available for estimating activity resources, there are various techniques used for estimating the required resources. The first technique is using expert judgment. In this technique, an expert in resource planning and estimating can estimate each of the activities. The next technique used is alternative analysis. In this, the activities are analyzed to identify different ways of completing them. This is to ensure only the required resources are assigned to each of the activities. This helps in resource optimization. Along with the two techniques, many organizations routinely publish their estimating data, and this could be used in activity resource estimation. Another technique that is routinely used in activity estimation is bottom-up estimating, which is decomposing the activity further down to understand it in more detail and estimating at that level. Later, all such estimates are added to arrive at the estimate of the activity. In real projects, one has to use all to estimate each of the activities. Sometimes, the project management software also helps in estimating. The software estimates are based on the inputs provided to it. Software should only be considered as a supporting tool in estimation and never fully rely on its output. Clearly, the output of this process is the activity resource requirements. Along with this, resource breakdown structure is also prepared. The resource breakdown structure is the categorization of all the required resources in various categories. That is, human resources, equipment, raw materials, etc. In the process of estimation, several other project documents may also be updated. For example, the resource estimates are directly correlated with cost estimates. Let us now move on to the next process: estimate activity durations. The next process is to estimate the duration required to complete each of the activities. The duration estimation should be done by someone who is familiar with the project. For example, the same activity, if done by a high-skilled resource, would take less time compared to a less skilled resource. This may vary regardless of the resource used due to the project requirements. In addition, the activity duration estimation should be updated continuously as you move ahead with the project, because as the project progresses, there will be more clarity on the project. The inputs of this process are similar to the ones in sequence activities process. Schedule management plan is the first input. Schedule management plan provides guidance in terms of methodology to be employed for many of the scheduling activities on the project. For instance, it may contain information about the estimation techniques to be employed and the people who need to be involved in the estimation process. Activity resource requirements is also an input to this process because resources assigned to an activity would significantly affect the activity duration. That is, the lower-skilled resources would take more time than the high-skilled resources. The other inputs include activity list, activity attributes, and resource breakdown structure. Resource calendars are also an input to this process. The type and skill set of resources available to the team may have an impact on the time it would take to complete the activities. Risks to the project may influence the decisions about the time required to complete the activity. Hence, risk register becomes an input to this process. The project scope statement defines the constraints and assumptions affecting the project duration. An example of enterprise environmental factor that can affect duration is organization's productivity metrics, which is collected based on the experiences from multiple projects. The last input in this process is organizational process assets. Now, let us look at the tools and techniques used for estimating activity durations. First is the expert judgment, which means using previous project experiences in estimating the current project duration. This can be used with other estimation techniques and used to reconcile differences if different techniques result in different estimates. Three-point estimating is a method where 3 estimates are used instead of 1. It is part of a project management philosophy known as Program Evaluation and Review Technique. PERT. Estimating activity durations is often done as a team exercise, as each activity may require multiple skill sets to be applied. Therefore, it is important to use group decision-making techniques to arrive at a consensus, or at least an estimate that is acceptable to all the team members. Reserve analysis adds buffer into the project schedule to deal with any uncertainty. The contingency reserve may be added as a percentage of the activity duration or fixed number of work periods. The other tools and techniques are analogous estimating and parametric estimating. The outputs of this process are the activity duration estimates and project documents updates. The activity duration estimates is represented in terms of the range of possible results. For example, 10 days plus minus 2 days, that is, the activity would take minimum 8 days and maximum 12 days. In the next screen, let us look into a business scenario to understand this concept better. After reading the problem statement, click the Solution button to look at a possible answer. Develop schedule is the process of analyzing activity sequences, durations, resource requirements, and schedule constraints to create the project schedule. It belongs to the planning process group. Generally, scheduling software is used for developing the project schedule. Entering the activities, durations, and resources into a scheduling tool generates a schedule with planned dates for completing project activities. Developing a project schedule is an iterative process. Revising and maintaining a realistic schedule is a task in itself, and it continues throughout the project as the work progresses. The most of the inputs of this process are the outputs of estimate activity durations process. They are risk register, project scope statement, project staff assignments, resources calendars, organizational process assets, enterprise environmental factors, schedule management plan, activity list, activity attributes, project schedule network diagrams, activity resource requirements, resource breakdown structure, and activity duration estimates. Various tools and techniques are used to develop schedule process. Schedule network analysis is a technique that generates project schedule. It employs various analytical techniques such as critical path method, critical chain method, modeling techniques, and resource optimization techniques to create the project schedule. The other tools and techniques include leads and lags, schedule compression, and scheduling tool. Let us now look at the outputs of this process. The project schedule consists of a minimum planned start date and planned finish date for each activity. Although project schedule can be represented in tabular format, it is more often represented graphically using either bar charts or network diagrams, or a combination of the two. The final schedule, which is the output of the developed schedule process, is also called schedule baseline. Once the schedule is baselined, it can be changed only through formal approvals. Meeting the schedule baseline is one of the measures of project success. Schedule data produced may include number of resources, key milestones, etc. Project calendars specify the available working days and the number of shifts in each day. It indicates how many hours and days are available for the work of the project to be completed. Project management plan updates are a result of the developed schedule process. Many of the other subsidiary plans of the project plan may get impacted, which may include cost management plan, scope management plan, risk management plan, etc. This may also result in other project documents being updated. In the next few screens, let us discuss schedule network analysis techniques. It is essential to know if the required resources are available at that time, along with the time estimate of each of the activities. Since schedule is calendar-based, it helps in estimating the same. Schedule network analysis technique generates project schedule. There are various schedule network techniques. Critical path method relies on determining the critical path on a project schedule. Critical chain method is a variant of the critical path method, wherein the critical chain is determined based on the logical, resource, and other kinds of dependencies between the activities. What-if scenario analysis is about trying to vary a certain parameter to observe the impact on the schedule. For instance, you may want to check result if you put in more resources on a particular activity to reduce its duration. Resource optimization techniques try to arrive at the optimal utilization of the resources used on a project. Ideally, you would want the resources to be fully utilized, but you would also want to build in sufficient buffers in case a certain resource is not available due to various reasons. In the next screen, let us look at the program evaluation and review technique. Program evaluation and review technique is based on 3-point estimates for an activity. The pessimistic estimate refers to the worst-case scenario, whereas most likely estimate is what you expect to happen in a realistic scenario. The optimistic estimate, on the other hand, represents the amount of time an activity would take in the best-case scenario. Based on these three estimates, the expected duration of the estimate is calculated as per the formula given on the screen. The formula for calculating standard deviation of an activity and variance of an activity is also given. There is no question asked on variance, but the formula is important because if the standard deviation of the whole project is to be calculated, the process is to calculate the variance of the whole project and then take its square root to calculate the standard deviation of the project. Concept-based questions on PERT can be expected in the PMP exam, so make a note of the formulae while you prepare for the exam. In the next screen, let us understand PERT with an example. Let us now figure out how we can apply the three-point estimation that PERT uses in order to draw some useful conclusions. Assume that the optimistic, pessimistic, and most likely estimates are 20, 70, and 30 respectively. Using these values, you can determine the expected duration and the standard deviation as indicated. Now, if the causes of variation are random, you can assume that the actual values would be evenly distributed about the mean and will follow the normal distribution, sometimes referred to as the bell curve. Further, you can use the properties of the normal distribution. There is a 68% probability of the actual value falling within first sigma from the mean, 95.4% probability for the second sigma, and 99.7% probability of the actual value falling within third sigma. Extending this logic, the notion of 6 sigma is reaching a level of confidence that only 3.4 times out of a million would the actual value fall outside the stated range. PERT allows you to plan based on the intended level of confidence in the outcome and determine buffers accordingly. Let us discuss the critical path method in the next screen. Critical path is defined as the longest duration path through a network diagram, which determines the shortest time to complete the project. Float can be considered as a buffer time available to complete an activity. Float is calculated once the network diagram is ready. It is also called as slack. There are 3 kinds of float. The first being the total float, which is the amount of time an activity can be delayed without delaying the project end date or an intermediary milestone. The second type of float is free float, which is the amount of time an activity can be delayed without delaying the early start date of its successor or successors' activities. The last type is independent float, which is the amount of time an activity can be delayed if all the predecessors finish at their latest finish dates and you want to start all the immediate successors at their earliest start dates. The slack of the activities on the critical path is 0, because there is no scope to delay activities on the critical path. Critical path actually represents the project duration. Delaying activities on the critical path is as good as delaying the project duration. Concept-based questions on critical path can be expected in the exam, so it is essential to have a clear understanding of the concept. In the next screen, let us learn how to calculate float. Float of an activity can be calculated by 2 methods. However, the first step in critical path method is to identify the critical path of the network. Once the critical path is identified, follow the forward pass to find early start and early finish for each activity. The float of the activities on the critical path is 0, so they represent the overall project duration. Use forward pass or backward pass to calculate the total activity time. Calculate late finish and late start using backward pass method. Note the total float formula before you start for the exam. In the next screen, let us look at forward pass and backward pass methods in detail. In forward pass, you can either go through the network starting with time 0 and keep calculating the time required to complete each of the activities until you reach the last activity of the project. The starting time for each of the activity in this approach is called early start, and the end time for each activity is called the early finish. Alternatively, in backward pass, you can travel through the network from the project end date and calculate the time required to complete each activity. The end date in this approach is called the late finish, and the start date of the activity in this approach is called the late start. The float of the activity is either the difference between the late start and early start, or the difference between the late finish and early finish. Both the differences work out to be the same. Before the start of the PMP exam, please make a note of the total float formula. Let us understand the critical path calculation with an example in the next screen. Let us look at an example for critical path. There are 5 activities in this project and 2 paths in the network diagram. Start, 1, 2, 4, 5, end is one path, and start, 1, 3, 5, end is the second path. Since the duration of the path start 1, 2, 4, 5, end is 18 days, which is more than the duration of the path start 1, 3, 5, end, the critical path of the project is start 1, 2, 4, 5, end. Let us take Activity 3 as an example. First, calculate the early start and early finish dates. Activity 3 can start only after Activity 1. Since the early finish of Activity 1 is 3, it becomes the early start of Activity 3. Activity 3 cannot start earlier than 3 because Activity 1 can be completed only by then. Therefore, early start of Activity 3 is 3, since the duration of the activity is 4 days. The early finish of Activity 3 is 3 plus 4 equals 7 days. Now, let us calculate the late start and late finish of Activity 3. Late start of Activity 5 is 14 days. The Activity 3 happens just before Activity 5, so the late finish of Activity 3 is 14 days. To calculate the late start, you can subtract the duration from late finish. Therefore, the late start of Activity 3 is 14 minus 4 equals 10. In the next screen, let us focus on schedule compression. Look at the 4 activities in the table. The normal cost of executing each of the activities, as well as how much each of the activities can be crashed, is also provided. Which activity would you crash to reduce the project time by 1 day? Activity A will be crashed if the duration of the project is reduced by 1 day, as the per unit cost of crashing the activity A is the least. All the activities are assumed to be on the critical path here. While crashing, if you end up saving time on a path, which is not the critical path, you will not end up saving time on the project. In the next screen, let us look into the impact of schedule compression. Different schedule compression techniques have different impact on the project. The impact of fast track leads to risk additions and increase in management time for the project manager. Crash leads to cost addition and increase in management time for the project manager. Reduced scope, on the other hand, saves cost and resources but increases customer dissatisfaction. Likewise, cut quality saves cost and resources but increases risk. Resource reallocation does not add cost or increase risk. In the next screen, let us look into the other techniques used in scheduling. There are several techniques that are used in scheduling projects. What-if scenario analysis. In this technique, questions like, what if a particular scenario changed on the project? Would that produce a shorter schedule? Are put forth to understand the impact of specific changes on the schedule. The goal is to produce a realistic schedule. Monte Carlo analysis. In this method, a computer simulates the outcomes of a project, making use of randomly generated values that map the probability distribution of the input variables. Together, these 2 techniques are called modeling techniques. Resource optimization techniques. These are also used to produce a resource-limited schedule. Resource optimization results in more stable number of resources used in the project. Critical chain method. This technique develops the project schedule that takes into account both the activity and resource dependencies. In the next screen, let us look at the last process in project time management, Control schedule. Control schedule is concerned with determining the status of the project schedule, determining that the project schedule has changed, and managing the actual changes as they occur. The project schedule is an important input to this process. It is the actual schedule that needs to be controlled. Schedule data contains information related to the schedule that may need to be monitored in order to take actions to bring the project back on schedule. Project calendar describes the working hours and days for the project. Work performance data has information like which activities have started, their progress, and which activities have finished. The other inputs of this process are project management plan and organizational process assets. The key tools and techniques of this process are the performance reviews. Performance review is measuring, comparing, and analyzing schedule performance such as actual start and finish dates, percent complete, and remaining duration for work in progress. The other tools and techniques include resource optimization techniques, modeling techniques, schedule compression, leads and lags, scheduling tool, and project management software. In development schedule process, these techniques are used for the first time to develop the project schedule, whereas in control schedule process, these techniques are used to update the project schedule. The key output of the control schedule process is the work performance information. This is represented in the form of schedule variance, SV, and schedule performance index, SPI. As a part of the control schedule process, the project team will generate forecasts, likely schedule for forthcoming activities, and project as a whole. The other outputs include organizational process assets updates, change requests, project management plan updates, and project document updates. In the next screen, let us look into a business scenario to understand this concept better. After reading the problem statement, click the Solution button to look at a possible answer. Here is a quick recap of what was covered in this lesson. Project time management includes the processes required to manage the timely completion of the project. A project schedule defines the start and end dates of the project and the project activities. These activities are assigned a duration and sequenced in a logical order. Gantt charts and network diagrams are used to identify project activities and determine the relationships and dependencies between them. Gantt chart displays the start and end dates of project activities, the overall project schedule, and the logical task relationships, while network diagram is used to plot the activity dependencies. Plan schedule management define activities, sequence activities, estimate activity resources, estimate activity durations, develop schedule and control schedule are the 7 processes under project time management. Schedule network analysis technique generates project schedule based on the estimates of time and resource requirements. With this, we have come to the end of this lesson. In the next lesson, we will cover project cost management.